Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Nucleophilic acyl substitution mechanism. Moving on to the next step. Identify the reaction. Acetyl chloride CH3C is equal to OCl reacts with ammonia NH3. The overall product of this reaction is acetamide CH3C is equal to ONH2 with loss of HCl. Moving on to the next step. Understand the mechanism. Nucleophilic acyl substitution proceeds via a tetrahedral intermediate. The nucleophile NH3 attacks the electrophilic carbonyl carbon of acetyl chloride. And for the final step, formation of the intermediate. When NH3 attacks the carbonyl carbon of CH3C is equal to OCl, the pi bond of C is equal to O breaks and the oxygen becomes negatively charged O, while the carbon now bears 4 substituents CH3, OCl, and the incoming NH3 which becomes N plus H3, protonated because it donated its lone pair. This gives the tetrahedral intermediate CH3C, OCl, N plus H3. A tetrahedral carbon bearing CH3, OCl, and N plus H3 groups. A CH3N plus H3 is simply methylammonium, not related to the acyl substitution mechanism. B CH3C is equal to O plus is the acetylene cation. This would be an intermediate in an SN1 type pathway, not the typical nucleophilic addition-elimination tetrahedral intermediate. C shows a carbon with 2 Cl atoms and an OH group, which does not correspond to attack of NH3 on acetyl chloride. Therefore, the correct answer is D. Therefore, the correct answer is option D.